It's homework time, yes! Happy. Homework time is here yet again. Lesson 10. Let's start off in the right way. Jot your name down at the top of the paper. I'll write my name. You write yours. And, hey, let's do things right. Write today's date. I'll write today, you write the actual date. Where and when you are in this wonderful world of ours. Our instructions for number 1. We are to shade the parts of the area models below, decomposing tenths as needed, and we'll come back to that, what that means, to represent the pairs of decimal numbers. See, here's a pair, there's a pair, and then there's C and D. Well, we'll fill in the blank with less than, greater than, or equal to compare the decimal numbers. So first thing to do, let's start with the easy one here. With an A, let's do 3/10 first, because this is already split into tenths. Now, you are welcome to do a better job than I am in your shading and such, because, I'm just kind of walking you through this, and your job is to make it beautiful. So there's 3/10. Easy enough, right? Now, to show 19/100ths, which is how we'd read this, 19/100ths, what we need to do is to decompose these tenths into hundredths. Now, the way Eureka does it, and which I'm not going to do because it ends up being too messy, quite honestly, in homework time world here, is the way they do in Eureka is they draw 9 horizontal lines here, which, it takes it to 100 little cubes. I found that that's ended up kind of messy for me. So what I do instead, and you should probably do it the Eureka way, because that's probably what your teacher's going to expect, probably what you did in class. But so there's my 1/10, right? Now I'm just going to decompose this one into tenths, this tenth into tenths, so into hundredths. So I can do my 9/100ths here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Because simply for me, drawing all those horizontal lines ends up becoming something of a mess. 2, 3, 4, 5, 6, 7, 8, 9. And so now I have 19/100ths compared to 3/10ths, which, I can note here, by the way, that 3/10ths right here, if I were to decompose that into hundredths, it would be how many hundredths? Well, 3 dimes, right? 3/10ths of a dollar. 3 dimes is 30 cents, right? And we'd write that like this. 30 cents, 30 hundredths. Does that make it, if you're wondering about this comparison, it's not just the picture, because we can do this without the area model, but we can reason it out here and say 19/100ths compared to 30/100ths. 19 cents compared to 30 cents, yes, is definitely a less than. All right, and then same thing here on B, and we're going to go a little faster through these 3, okay? Now that I explained that first one at length. 1, 2, 3, 4, 5, 6 tenths, 6/10. Now this, what's up with that? So if this is 6 dimes, right? And let's even write this out as hundredths now, like we did on the last one. 6 dimes is how much money? 60 cents. And what does that look like but this? 60 cents, 60 hundredths. And then this is 6 hundredths. So 6 pennies, 6 cents. And so again, in Eureka land, they would draw the 9 horizontal lines. I found it just ends up kind of too messy for me in my little computer world here. So I'm just going to draw 1/100th rather, 2 hundredths, 3 hundredths, 4 hundredths, 5 hundredths, 6 hundredths. And now you can see the difference between 6/10ths and 6 hundredths. Look at the area models. Which is more? Obviously 6/10ths is, and we figured that out rationally as well. 60 cents is more than 6 cents. So this is a big old fat greater than. 6/10ths is more than 6 hundredths. 60 cents is more than 6 cents. Let's go hit C and D. Is more the same. Oh, what's up with this? 1 8/10ths compared to 1 53/100ths. Well, they're both 1, okay? See, and notice they don't give us enough area model diagrams here to really do both of these as written. So here's a way of dealing with it. We know that they both have one whole, So we don't really need to compare that. They're equal. They might as well not exist. It's like if we had one whole cake over here and then some more, and one whole cake and then some more. We just really have to compare the and some mores and push those whole cakes aside because those, they each have one whole cake. All right, push them aside. Cake. All right, so here's how I'll show that in the area model because although in Eureka Land they don't, I like to. Look, there's one. There's the one whole. That's it. That's all I have to do. Say there's one whole. And over here for this area model, there's one whole. And you see, they kind of make eyes, and so there's the nose and the mouth. There we go. Happy, happy area models. So now I only need to look at the 8/10ths and the 53/100ths. And while we're at it, let's note that 8/10ths is how many hundredths? Well, 8 dimes is 80 cents. So 8/10ths is, that's a zero really, 8/10ths is 80 hundredths, okay? And now we can easily compare, and before we draw the area models, 80 hundredths, 53 hundredths, I can see where this is headed. All right, so let's scribble in 8/10ths here. 3, 4, 5, 6, 7, 8. Okay, good. Looks good to you? Looks great to me. And again, feel free to do a better job than I do. Now over here, I'm going to do, again, in Eureka Land, yes, they would decompose the entire grid, but it ends up too messy for me, so you can do it that way, feel free. But I'm going to do it this way. I'm going to do my 3, 4, 5/10ths, and then 1, 2, 3 hundredths. 5/10ths and 3 hundredths. 5/10ths, 3 hundredths, okay? So now we can look at the area models, and it confirms what we already knew, that 8/10ths is indeed more than 53 hundredths. So that means that 1 and 8/10ths, see there's our 1 and 8/10ths, is more than 1 and 53 hundredths. So this is a big old greater than. All right, now let's look at this next one. We have 38 hundredths to start with. So 1, 2, 3 tenths, and then 8 hundredths. 1, 2, 3, 4, 5, 6, 7, 8. All right, so then there's 8. 1, 2, 3, 4, 6, 7, 8. Okay, I did it right. All right, so 38 hundredths, there we go. And we're comparing that to 7/10ths. And hey, let's take that moment and say, hey, 7 dimes is how much money? Yeah, fix that. 7 dimes is 70 cents, right? So 1/10, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths. Amen. All right, and you can look at our area model, and you can look at our reasoning here. 38 hundredths compared to 70 hundredths. Look at the area models. It's clearly less than. And let's go on to number 2. In number 2, our instructions are to locate and label the points for each of the decimal numbers on the number line. Then we'll fill in the blank with less than, greater than, equal to compare decimal numbers. So let's do that. 7 and 2 tenths. Now look at our number line. It goes from 7 to 7 and 3 tenths, making stops along the way for 7 and 1 tenth, 7 and 2 tenths. So 7 and 0 tenths, 7 and 1 tenth, 7 and 2 tenths, 7 and 3 tenths. And maybe I'll help you to think of these in terms of fractions. 7, 7 and 1 over 10, 2 over 10, 3 over 10. Okay. So 7 and 2 tenths is actually one of our points here. So there it is. And it's already labeled, so I don't need to write 7 and 2 tenths. It's already there. Now 7 and 2 hundredths. Think about it. Let's go to our good old friend money. This you might read as 7.1, 7 and 1 tenth. How much money would that be? Well, that would be $7.10, right? If that were money. So this would be how much money? 7.02, 7 and 2 hundredths. That'd be $7.02. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cents. So where is $7.02? Yes, it is right here. That is 7.02, 7 and 2 hundredths. Because this is 7 and 10 hundredths. You see the logic there? These number lines can be tricky, my friends. So now we can clearly see that 7 and 2 hundredths is much less than 7 and 2 tenths. Or I could say 20 hundredths, right? Let me just write it out that way so you could see it. 7 and 20 hundredths compared to 7 and 2 hundredths. So 7 and 2 tenths, $7.02 compared to $7.02. That is a big old greater than. All right, and similar phenomenon here. We're starting our number line at 18 and 1/10, going to 18 2/10, 18 and 3/10, 18 and 4/10. I'm not just wasting your time. Take your time to really understand what you're doing, or you will just get stuff wrong and you won't even know why. So don't leave me comments saying, hey, you talk too much. I'm explaining it so you'll understand it. Goodness. All right, so let's do the easier one first. 18 and 3/10. I mean, that's right there, right? We can see it. There it is. 18 and 3/10. Cha-ching. Done. All right, now we're going to go to 18 and 19 hundredths. Well, if you were counting, 17, 18, 19, 20. Look at this here. This would be 18. This 18 and 2/10 would be 18 and 2 dimes, $18.20. And this, of course, would be $18.30. 18 and 20 hundredths, 18 and 30 hundredths. Okay, we see that. So 18 and 19 hundredths, $18.19. Yes, would be just a line here before the $18.20. So there is, do I have the gnat in here? All right, I'm going to write it up top because I don't really have room underneath. $18.19 or 18 and 19 hundredths. Hallelujah! And when we look at our number line, we can see, okay, that falls before. So 18 and 19 hundredths is less than 18 and 30 hundredths, also known as 18 and 3/10. Booyah! Let's go see about number 3. And in number 3, we are set free! Hallelujah! No more area models, no more number lines. We're just using less than, greater than, equal to compare. Let's do it. They start us off with one that's pretty straightforward. 2 and, it helps to read the numbers correctly, 2 and 68 hundredths compared to 2 and 54 hundredths. 2 and 68, 2 and 54. Yes, 68 is more than 54, right? Because we're talking about hundredths in both cases. Now here again, both numbers go out to the hundredths place. 6 and 37 hundredths, 6 and 73 hundredths. Well, 6 and 37 hundredths is going to be less than, right? 6 and 73 hundredths. So that's a nice little less than. And notice here, we don't even have to write a sentence as we did in fraction world to explain our reasoning. Look at C. C is there to make sure you get it, because it's 9 and 28 hundredths compared to 7 and 28 hundredths. And they just want you to understand, like, hey, they can have the same hundredths going on. But if the whole number here is more than the whole number there, it's more. 9 is more than 7. Doesn't even matter about the 28 hundredths. 9 is more than 7, period, done. That's it. You can compare the highest place value and say 9 is more than 7, done. All right. Now this one, we might have to think just a wee bit. All right, 3 and 2 hundredths compared to 3 and 2 tenths. Well, let's look at that 3 and 2 tenths because it's not in hundredths. So it's $3 and 2 dimes. 2 dimes is 20 cents. So look, if I write this 0 here, that's equivalent, right? They're equivalent fractions or equivalent decimals. 2 tenths equals 20 hundredths. I'm going to write that over up above so you can see, look. I write it as a fraction. 2 tenths equals 20 hundredths. This is an important principle. That's why I keep kind of hammering on this one. Now it's easy to compare, right? $3 and 2 pennies compared to $3 and 2 dimes. 20 cents compared to 2 cents. 2 cents is less than 20 cents, right? So it is less than. We see why. And now here, 13 and 1/10 compared to 13 and 10 hundredths. Well, look, just like we did in that last one, 1/10 is actually equal to 10 hundredths. Keep that in mind. I'll read these numbers again. 13 and 1/10 compared to 13 and 10 hundredths. Those bad boys is, yes, equal. You got it. They are equal. They are the same. $13 and 1 dime compared to $13 and 10 pennies. It's the same. Same amount of money. All right, and lastly here, 5 and 8/10 compared to 5 and 92 hundredths. The error here is to say, well, 92 is more than 8. Well, that's true, but that doesn't necessarily, it might mean, but it doesn't necessarily mean that that's the greater one. You have to think about it. 8 dimes would be 80 cents, right? So I can place this as 0 here because, hey, it said 8/10, and I know that's equal to 80 hundredths. Those are equivalent fractions, equivalent decimals. That's a 10, really. And that makes it easier to compare now. 80 cents compared to 92 cents? Well, yes, indeed you do. It is less than. And look at that. We're almost there. Let's go see what joys number 4 has in store for us. Squeak. Number 4, same idea as number 3, but they're messing with our heads. Instead of just giving us 2 decimal numbers to deal with, maybe in tenths and or hundredths, now we're going to have numbers that are in decimal form to the tenths or to the hundredths. We're going to have fractions as mixed numbers or as improper fractions, as you see in E, and we are even going to have numbers in unit form, like we start off right here, 57 tenths. And so in each case, we are going to need to do a little bit of interpretation. Now, I'm not going to need pictures to solve these. You're welcome to draw all the pictures you want. I really can't imagine you drawing an area model for each of these. It seems a little weird. But we can do the math. In fact, we should and need to do the math. So 57 tenths. Let me show you the way to think about this. I'm going to write the number 57 such that it ends in the tenths place. That will be 57 tenths. Same as if I were writing 57 hundredths, I would write 57, the 7 would be in the hundredths place. 57 tenths, the 7 is in the tenths place. So let me write 57. Now this is the tenths place. Where's my decimal? Ah, yes, it's here. 57, what place am I in? Tenths. That's confusing. It is. And I'll tell you, in the real world, nobody calls this number 57 tenths. I mean, you might say, hey, I have 57 dimes, in which case someone will say, congratulations. You can go buy a piggy bank to put them in, and then you'll have no money to put in the piggy bank. But so 57 tenths looks like this. You need to be able to kind of reason it out, and if it helps you to think of it in a fractionated form, that's not a word, there's 57 tenths, right? How many tens in 57? Well, there are 5 with 7 tenths left over. 5 and 7 tenths, 5 and 7 tenths. So if you're taking a test, whether it's one of those standardized tests, a paper and pencil or computer, or it's your Eureka Math mid-module, end-of-module assessments, this is something you can do. So when your teacher's saying, check your work, this is what you can do to check it. All right, so enough of that. So 5.7, 5 and 7 tenths, and we're comparing to 5 and 7. Yeah, okay, they're equal. Well, you can see it now. Great. So 6 and 2 tenths compared to 6 ones and 2 hundredths. Okay, so watch. So I'm actually going to make a miniature place value table here. Ones, tenths, hundredths. Okay? 6 ones. Z, decimal point. Rah. Tenths. Ah, I have no tenths. No tenths. 0 tenths. But I do have 2 hundredths here. So the number I would write out here is 6.02, 6 and 2 hundredths, compared to 6 and 2 tenths, which, come on, we know by now, that's 6 and 20 hundredths. So 6 and 20 hundredths compared to 6 and 2 hundredths, yes, greater than, yes. 33 tenths, same as this annoying 57 tenths here. So I'm going to write the number, I won't belabor it this time. I'm going to write the number 33 such that it ends in the tenths place, which means my decimal goes here. 3 and 3 tenths, 33 tenths. And again, as a mixed number, it would look like this. As an improper fraction, 33 tenths would look like this. We see how that works, right? Boom. All right. Now our other number here is 33 hundredths. I'm going to write it 33 such that it ends in the hundredths place. So this would be the hundredths place. This would be the tenths place. My decimal is here. This would be the ones place. 0.33 is 33 hundredths, is it not? Yes, I could write it in fractionated form like this. All right, and I can easily compare these now. $3.30, because I can do that, right? It's equal. That's a horrible zero. Fix it. All right. $3.30 compared to 33 cents? Oh, come now, children. Yes, it is greater than. All right, now let's look at this one. 8 and 39 hundredths. Boy, are they messing with us on this one. Ooh-wee. 8 and 39 hundredths compared to this wackadoodle number here, 8 and 39 tenths, which is kind of one of those in-between step mixed number with an improper fraction. So we have to kind of decompose this bad boy here. And we say, hey, this is 8. We got 8, right? 39 tenths. Well, how many tens in 39? There are 3, because 3 times 10 is 30, which leaves how many tenths? Right, from the 39 it leaves 9 tenths. Put those together, what do you get? 8 and 3 are 11, and then we have this here 9 tenths hanging out. Yeah, you see? And now it's clear, right? 8 is less than 11. We don't need to look at the fractional part, the decimal part here. We can say that 8 is less than 11. Boom. Okay, that one's pretty wacky, huh? In 236 hundredths, there's a couple ways we can look at this. I can write the number 236 such that the 6 is in the hundredths place, because it's 236 hundredths. So if this is the hundredths, then this is the tenths, and this is decimal point, and this is the ones place, right? There's my little place value chart. Ah, and look at that. The other way I could do it is to turn it into a mixed number, which would give me 2 and 36 hundredths, which you can then convert to a decimal form just like that. So we can see quite easily 2.36 equals 2.36, 2 and 36 hundredths. Lovely. Last one! Whoo, yeah. Tea break. That's a Fireside Vanilla Spice. Good one. All right, so 3 tenths. Hey, we can write 3 tenths. We know what that looks like. A 3 in the tenths place, right? And we can write 22 hundredths. We know what that looks like. We write 22 such that it ends in the hundredths place right there. Now to make this just a little bit clearer, 3 tenths we know is equal to 30 hundredths, just as 3 dimes equals 30 cents, right? 30 hundredths compared to 22 hundredths, 30 cents, 22 cents. Yes, that bad boy is greater. And look at what you've gone and done. Again, you've completed another homework time. Fabulous work, baby. I'll see you again next time. It is once again homework time. Squeak.